Hello, everybody. So, what this is going to be is our first lecture on making a game in Java. And so, the game that we're going to make is going to be Breakout, which, if you haven't seen that before, it's easy to find. If we just kind of Google Breakout Arcade, you'll find a lot of versions of this game if you've never seen it before. Maybe I should have done a video. Maybe I should have just said game. Yeah. So this is a pretty basic game, right? So we'll just grab a screenshot here. And so you've got a paddle on the bottom, paddle moves left and right. There's a ball, the ball bounces off the paddle, and you're trying to break all of the bricks, which are arranged in a grid up here. And that's the game, right? When you clear out all the bricks, then you just get a new level. Maybe the ball moves faster, that kind of thing. So it's a pretty simple game, but it's about as complicated as we can do for like a first game in Java. Games that are more complicated than this have kind of too many moving parts for a first, like, learning how to make a game kind of thing. So anyway, we're going to make Breakout, and this video is just going to cover like getting the project started, okay? And like an overview. So lecture one. So what are we doing? So we're going to make a classic brick breaker arcade game, right? And so little picture over here of just what we talked about, right? Paddle on the bottom, ball, bricks. Okay. And we're going to write that in Java because this is a Java class. And we have decisions to make, although we're not going to spend any time making them about how to do that. And so we're going to use kind of basic classes or packages that are built into Java, and so AWT and Swing are kind of the most basic way of getting Windows up on the screen. Okay. And the structure of the project that we're going to use is we're going to have one class per game object. And that's really standard on kind of smaller games like this. Um, for more complicated games, you might have not one object per class because you might need one class to handle several different kinds of things. But for us, we're going to be using one class per game object. That's going to mean one Java file. And so you need to make sure that you're familiar with the concept of classes, which is in um, the week 5 material, I think, if you're in summer session. And yeah, and so we're going to make our game run at approximately 60 frames per second. I say approximately 60 because this AWT swing class that we're going to be using for drawing the windows actually can't update the screen at exactly 60 frames per second because of the way that it times things. So it'll be around 60 frames per second, plus or minus. And we'll just use a keyboard to control the paddle. Okay. And so the structure that we're going to come up with for this is going to be as follows. So every game object lives in its own Java file. So there's going to be a main.java, and that's going to draw the window, and it's going to refresh itself at 60 frames per second. And any kind of the game logic is actually going to be in this file. You don't have to structure your game that way. What a lot of people would do is basically the main.java would just create an object for the game, which is in its own class. But that's one extra file to do that. And the main.java may as well just do everything for us. So we're going to put our game logic in this main.java. Okay. It's also going to handle the input from the keyboard. Then the stuff that can be on the screen is going to be each in its own class. So that means we're going to have a paddle.java that's going to have our paddle in it. And that's going to have, like, for example, the paddle has a position and it has a size and it has a speed. And also it has methods, right? Functions that we can call to draw itself on the screen. Also, at some point, we're going to need collision between the ball and the paddle. And that could either be in the paddle or it could be in the ball, whichever way we decide to program it. But we don't need to worry about that now. So similarly, the ball is going to be in its own class, so ball.java. Um, a brick is going to be in its own class, and then all of the bricks are going to have their own class. And so this is something too that is going to be new, and that's where we're going to have a class in a class. And it makes sense to do it this way because when you're looking at the game, right, one brick, like this brick right here, has a position, it has like a width, and it has a height, it has a color, and we're going to need to know if the ball hit this brick in particular. And if it did, we need to delete this brick, right? So one brick has a bunch of things that it needs to do. But we don't just have one brick, we have, many bricks. And so um, one brick doesn't know about all the bricks. So you put or you write a brick.java that's just a brick, and then we're going to make a whole bunch of them, and we're going to put all of the bricks into a grid. We could call it brick array or something, but all of the bricks can just go in this class, and that could have its own methods and so on. So this will keep track of all the bricks together. And that way is of structuring the project is fairly reasonable. Um, keep stuff relatively separate. We can understand what should be where. It's not that hard to code. It's not too many files to manage, and it tends to work well for a game of this size. Okay. Now, each of those classes is going to have some of the stuff that we've already talked about. Like this is an example using like what we're probably going to be doing for our paddle class, which is going to be in the next video. So, um, like our paddle might have an X and a Y position on the screen, and it might have a width and it might have a height, and it might have a speed. So that's how many, every frame, how many pixels can the paddle move? Um, right? So it doesn't move too fast or too slow. And it should have a color. It could have multiple colors if if there's some design you want to draw on it, we could store those in different colors. And so this is data, which we call fields, and that will go in the paddle class. But also the paddle has to do things, right? It doesn't just have data, it also has to do things. And the doing things is methods. So we'll have a method that can move the paddle left by a certain amount. We'll write a method that can move the paddle right by a certain amount. We'll have a method called draw, and it's just going to draw the paddle on the screen. Now, in order to get kind of the window to draw in, that's what this graphics G is. So G is like our window. So we're going to draw the paddle in this window. And then we may need to be able to get the bounds of the paddle, and we could use that, for example, to find out if the ball's hitting the paddle and so on. And, we can add more to it as we go. Okay. So as it says down here, the ball, the brick, and the brick grid follow the same pattern. Each class owns its data and knows how to draw it itself. Okay. So when you're getting started with like a simple game in any programming language, this goes for this Java, but it also goes for anything. And I really do mean this, right? So it says like right when I say like just use an AI prompt to scaffold the boilerplate. So in programming, what boilerplate is it's like the code that has to be there. It it's doesn't have anything to do with our game. Like we don't care about this code, but it's just the code that you need before you start. Um, for example, how do you draw a window? We don't know how to draw a window yet, right? Um, how do we draw anything in the window? We haven't figured that out either, right? How do we refresh it at 60 frames per second? We don't know. How do we get the input from the user? We don't know. And of course, you can look that all up in the documentation, right? Or you can find a sample project that does all that, and then you can strip out what you don't need. And that's what a lot of people would have done in the days before AI, is they would Google for kind of the simplest possible program that does what they want, and then they would just take out anything that they don't need. Okay. But in the days of AI, like we are now, this is a perfectly legitimate use of AI, even if you want to do all the programming yourself. So, um, what you would do is you just come up with a prompt similar to this one, and you just put what you know about what you want to do. So, I want a single file main.java. I know that that's what we're starting with. And I want to use basic packages, and I know the names of them, so I put them here. But if you didn't, you just leave that out. I know how big I want the window. I'm going to be drawing 800 by 600. I know I want it to have a black background, although we could change that later. I know I want it to refresh at 60 frames per second, although I know that it won't actually do that. Not exactly. And I know that I'm going to want to move stuff around on the screen. And so, even though we're not going to use it, I'm going to put a green rectangle on the screen, and I want the rectangle to be able to be moved left, right, up, down with the arrow keys. And so what that'll let us do is it'll have an example of getting the input from the arrow keys, and also, an example of something moving around on the screen. So this is like the simplest thing we could start with here. And so you take something like this, it doesn't matter if it's exactly this, and you put that into some AI something. So like I can go ChatGPT. Um, I usually use Claude, but I'll use ChatGPT for this. And so I'll just paste that right there. And whatever it gives me here, we'll just take it the way it is, and then we'll see what we got. We can read what it says down here. It says this creates an 800 by 600 window. It's using a black background. It refreshes at approximately 60 frames per second. It draws a green rectangle and moves it right. So it says it does everything we asked for. Okay. So with all this done, go back up here. Let's just copy this. And then let's head over to Eclipse, which I have the Zoom stuff is in the way. There is Eclipse. And so we would get started like normal, where we would create a new project. And I'll just call this like Breakout, even though it's not going to be Breakout yet, right? But I'll call it Breakout Lecture 1 or Part 1. Maybe I'll call it Part 1. Part 1. I'll uncheck the box for create module info.java. There we go. So there's my breakout. I will do a new class in there. I'm going to call it main, capital M, main. And doesn't matter if I check the public static void main, because we're going to just, whatever's here, I'm going to delete it. And then I'm going to paste all our stuff. So let's save this and we'll run it and we'll see what happens. Okay, so this is what we have. And if I move left, right, up, down, let's see if the rectangle moves. Left, right, up, down. What about WASD? Oh, those work too. All right, cool. So it does exactly what we wanted. Perfect. So let's take a look at this, see what we have in here. So looking at this, you can see at the top that we have javax.swing imported. Um, we need that for the graphics that we're going to be drawing. Um, and then we have AWT and AWT.event. AWT also has graphic stuff, and it also has the keyboard handler that we're going to use. So the fact that we can type or that we can get keyboard presses, that's coming from the classes here. Now it says public class main extends JPanel. JPanel is a window. So this we're saying we're going to be drawing a window, and it says action listener, key listener. That means we're going to be able to read the keyboard. And so, again, you would have had to look this stuff up if you didn't have AI write it for us. What else do we have? We have a width and a height, just specified here. Um, the rectangle. So what did it do? It took the width this is like a little more complicated than it needed to be, right? What it did was it took the width of the screen, which is 800 pixels, divided by 2 to get 400, and then subtracted 25. So it's trying to put the rectangle in the middle. Because like if I were to change this to x equals 0, y equals 0, like this, and I run it, you can see now the rectangle starts out in the corner. So 0, 0 is up in the upper left, and we'll need to know that, which is part of the reason why I just did this. But 0, 0 is up in the upper left corner. And then as you move down, that's the y value. So like this is done here. This is like actually not y equals 600. Y equals 600 would be like off the screen. Um, and then you can move all the way to the right, and that would be the x value, right? So x equals 0 is up in the upper left. X equals, I guess, around 800 is over here. And then down here would be like 800 comma 600. Although again, it's actually the corner that's 800 comma 600, and the position of the rectangle is technically this upper left corner of the rectangle. So you do have to be careful. That's why I wasn't saying that the rectangle's at position 800. It's actually the edge of the screen is 800, and the rectangle is 50, or square is 50 pixels. So that's actually 750 is right here. So the position is 750. Okay, rectangle size, speed is 5. So 5 is 5 pixels. So like when I'm holding right, it's moving 5 pixels per frame. So if you change that to like 25, then it should be zooming, right? Okay. Key states up, down, left, right. This is unnecessary, but we had AI write this, so it wrote what it wanted to write. Then this is our main class. And so it says set preferred size. So that's going to be our window size. Background color is going to be black. So you can see how to pick a color now. Color dot black is black. Down here, you can see color dot green is green. We can get the exact colors we want if we know the RGB values for them. Set focusable true. Also, if we run this, I think, ah, actually it did it. It did something that they don't always do, which is I cannot resize this window. And that's going to be set down at the bottom. We'll see it when we get there. Then down here, set focusable. That means, you can select the window, add key listener. That's so we can get key presses. And then we set a timer. And the timer is set to 1000 divided by 60. And so 1000 is 1 second, 1000 milliseconds, and we're dividing it by 60. So 1000 divided by 60 is how many milliseconds our timer is. So if you grab a calculator, 1000 divided by 60 is 16.66666 milliseconds. And the reason we can't have exactly 6 or 60 frames per second is because that's an integer. And so it'll be 16 milliseconds. So this will be an integer here, 16 milliseconds. So we'll get slightly more than 60 frames per second. And that's why it's approximately 60, not 60. Cool. So this is our kind of our main um, class stuff here. Then if we scroll down, we have paint component. So this is everything we want to draw. So you see what we're going to do eventually is we're going to draw everything in here. Bricks, paddle, etc. So that all goes here in the paint component. And then down here where it says action performed, um, this is going to be if we need to move anything around on the screen. So this is where stuff gets moved around. And so what's happening here is if you're pressing left, we're going to move the rectangle X position. So, right, These are the X and the Y position for that rectangle. So we're going to move them. Um, when we're pressing left, we subtract from the X value, and to move right, we add to the X value. So that's why the minus equals and plus equals. Similarly, if you're pressing up, we subtract from the Y value, and if we want to move down, we add to the Y value. That's because zero is at the top, so like if you go towards zero, you're moving up. And if you move to a bigger number, you're moving down. Okay, and here it says keep rectangle inside the window. So let's just run this. So like if I try to move this off the screen, it actually hits the edges and stops. It doesn't go off. And that's because of these lines of code here, which are stopping it from leaving the screen. So like if I comment those out and run it again, now you see it just can go right off the edges of the screen and we don't even see it. Um, so you can do this in other ways as well. Like you could say if like the rectangle X position, if it's like less than zero, then we can set it equal to zero. Oops, rect X. Like, so if you do something like this, what that's saying is now if you try to go off the screen to the left, it doesn't let you. And you could do the same thing if rect X greater than, and our Windows 800, right? So you could do that. You could say rect X equals 800. But what you'll see if you do that to try to keep it on the right side is that it actually looks like it's leaving, right? And that's because, again, the position is being measured from the corner. So if you want it to not go off the edge, you don't want to stop it from going past 800. You actually would want it to stop going past 750. See, now it's stuck there between 0 and 750. So that's pretty simple logic, right? You could do that for anything that, could possibly move off the screen. And then it says action performed, and then at the end it does repaint. So after we've moved something, we should draw the screen again. Although probably that might not even be necessary. Oh, yeah, yeah, it is. And then this is how input works. So again, we would have had to look all this up, but when you have an example, it's easy to see what's happening. So they use a switch statement and it says key event VK left. That's the left arrow key. So if you're pressing the left arrow key or you're pressing A, then left is true. And if you're pressing right or you're pressing D, then that's right. And if you press up or W, that's up. And if you press down or S, that's down, and so on. Once we get further on, we're going to do something like this too. We're going to have like a key event dot like VK underscore, thank you, autocomplete. We'll want to get the space key. For now, we're not doing anything with it, but you want to maybe have a way to pause the game, for example. So any extra keys you need, you can just add a little case statement for them in here. And then this just is when you let the key go, then you set those back to false. Okay. Key typed. We're not typing, so this is just nothing. You can probably just delete that. And then at the very bottom, this is setting some of the stuff for our window. So like when we run this, you'll notice that the title says movement demo. And so that's right here, right? So you can change that to breakout part one. And then it says default close operation, exit. So when you close it, it closes. Set resizable false. We want that because if you set resizable true, or if you left this out, then you'd be able to do this. And you normally don't want them to be able to change the size of your game like that. So I'll have it like that. And set it visible so we can see it and so on. So yeah, so there you go. So that's just what you need to get started, right? So we don't have a game, but we got a window. We have a window and stuff can move on the window. And that's really all we need for the moment. Okay. And so I think you can start to see like what we're going to do is we got this rectangle that we can move around. And so the next thing we're going to do is we're going to write a paddle class. So the paddle is not that much different than the rectangle though, is it? Right? So um, the paddle is probably going to be a rectangle like this one. So it's going to have a position and we're going to be able to move it around and it's going to know how to draw itself on the screen. And that's all we'll need for the next video. Okay. So hopefully this was useful and interesting, and I will get the next video up as soon as possible, probably at the same time as this one, actually. So that's it for now. I will talk to you guys later. How do I stop this? I ask myself that so many times. Where's the stop recording?